No.
Who watches this, Mr. Rivers?
Me.
Just you?
Well, you know, for the longest time, as a football coach, I would break down game film. You know, that's what we do. And about a year ago, I started looking a little bit more at myself as how I
Hi,
teach.
Ethan.
You know,
All right.
How are you today?
okay, now you have a few minutes because we're not going to get to the full
You're trying to
part.
really awaken the
Oh, is it that line? I'll go.
You were turning bad.
Okay, so what we're going to do is,
9:30. I get 9:40.
they're going to do some work.
It wasn't that late. You're gonna laugh.
We won the last time. We were in
So what elements, what parts of your experiment remained constant, didn't change yesterday? What remained the same? Now, you know, what remained constant, didn't change? Well, the trade didn't change, but I'm not sure that's significant. What are some other things, wait for a second, what are some other things that didn't change? Answer, honey, or question? Answer. Sit up on the edge of your table when you're ready to share. Sit up on the edge of your table when you're ready to share.
You ain't ready about.
Right, here's down. Maybe one thing, maybe two things, maybe three things. What didn't change? Trade didn't change. What else didn't change? What were constants? Okay. And Chris, give me a number between 1 and 25. 1, 2, 3, 4, 5, 6, 7, 8. The height. Who had the height? Who had the height? Okay. Who didn't have the height? Who had something different? Oh, now think through it. Think it through. What else, hon?
The stuff we dropped.
Do you think that made a difference?
Yes.
The stuff. What else could that stuff be? Say again? Water. Be hard to. I'm not saying we couldn't do it. What else could it be though?
Well, it could be like anything else because.
Anything else? But what anything else be? What, if we were doing this experiment tomorrow, what else could it be? Salt. What else? Sugar. What else? Sand. Confectionery. Sugar. Say again? Cake mix. That's kind of cake mix when you really think about what cake mix is. Things that are not solid, things that aren't liquid, things that are gooey. Pancake batter. Icing. Oh, don't bring up your nose on me. That's good stuff, that pancake batter. Okay. So your constants were, okay, now we're going to get goofy. The constants was the flour and the cocoa, the height you dropped it at. Those never changed. What if they would have changed? What if you would have picked something, if we would have emptied them and tried something different every time? Would you have answered your question? Could you have answered your question? Be harder, why not? Go ahead. Change too many things. Change too many things. Very good, very good. Thank you very much. Have a seat. Did you take out that sheet from yesterday? Oop, you're fine. Pardon? No, you're fine. You're perfect. You're perfect. Right where you are. Your data sheet is out. Your lab packet from yesterday is out. We're down to number 10. We're down to number 10. What are your variables? What are your independent and dependent variables? Talk it over at your table. Pick a spokesperson. You've got 90 seconds. 90 seconds. I want to know the answer to number 10. What are your independent and dependent variables?
I couldn't remember my grade like that.
30 seconds. 30 seconds. Spokespeople stand as soon as you've got your answer. What are your independent and dependent variables? I got one spokesperson. 2. Closing in on the time. Come on, spokespeople. Dylan's up for 3. All right, 4. Thank you, Caroline. 5, Ely. Doug, you're going the wrong direction. You're supposed to stand up. No, oh, there you go. You were worried me there for a minute. Who's your spokesperson? Come on, Deshaun. Congratulations, Deshaun. Qualified in 2 events for the honor roll. Actually, you qualified in 3. Well done. You guys got one yet? What's your independent? What? Very good. Very good. Quincy, pick me a number between 1 and 7. 7. 1, 2, 3, 4, 5, 6, 7. Dylan, what do you want to do? Do you want to do independent or dependent variables?
I'll do dependent.
What you got?
I did the object or the ball that was used.
What did the object or the balls depend on?
It depended on like.
Yeah.
What?
A dependent variable depends on something. What were the dependent variables?
So like,
Keep going. Keep
would it
thinking.
depend on like us?
Okay, so that's really not dependent, that's really independent. The independent variables were what? Ely?
The balls and
The independent variables were the different balls. Because you got to choose independently. You came up and you chose independent. Now think about the learning check yesterday. Independently you picked, oh I'm sorry, up here. Independently you picked which objects you were going to drop. So if Dylan's right that it's the balls that are the independent variables, Ely, what are the dependent variables? Give me one.
ejector. Or, yeah, ejector.
Eject is not a measurement.
Or length of each.
A length of ejecta. Nick, what's one more?
Crater depth?
Crater depth and Caroline? Yeah, you do it. Now think. He did length of ejecta. He did crater depth. Very good. Miles, you got anything to add? You good? Anything? Okay, very good. Thank you. Thank you. We have diameter and depth. Turn the page. Scientists analyze and interpret data. Scientists use mathematics and think like mathematicians. Part A is constructing a line graph. Part B is constructing a line graph. Part C is looking for the pattern and writing about it. Part D is looking for the pattern and talking about whether or not your hypothesis has been supported or not. And E is asking for a relationship. Now here's the deal. Use the graph paper on the back of your lab. Would you turn and look at the graph paper for me? I'm gonna heighten your sense of urgency. We're gonna display these on the projector so that everyone can see your work, so it's your best work. Notice that this one that I have has depth in millimeters on one side and mass in grams at the bottom. This is for a particular graph. You have to figure out which one that's for. Here's one of the questions that came up in first hour today. How do you convert centimeters to millimeters? And shame on me, I thought that was pretty easy. It wasn't for some people. If one of your answers was 3.6 centimeters that you recorded, how would you convert that to millimeters? Maddie? Pardon?
Right, no,
No, honey, just slow down for a minute. I just didn't hear you.
times by 10.
Times up by 10. And you're absolutely right. What would I do with the decimal point? Move it over
Right.
to the right
One
one place. So it becomes 36 millimeters. And the reason why, if you look at your graph, and I didn't let you choose the interval, I chose the intervals for you. 36 versus 15 versus 12 is going to be a lot easier for you to see the pattern than if you kept it at 3.6 and you squeezed it right in. It'd be very hard to see if there was a pattern at all. So when you make graphs, it's always your choice to decide what the interval is, but you want to use one so that you can explain what the data is actually doing. All right, looking at the clock, 7 minutes. 7 minutes, I want 2 graphs drawn. 7 minutes. Should your graphs look alike at your table? Yeah, they should be exactly alike, right? So you can help each other out here a little bit. Ms. Ash, I'll walk you through the steps. Dr. Roberts. Apple TV sits on top. You need to borrow one? Yeah, it does.
You have to divide it by 36.
I'm sorry?
That's,
Yeah, she made that.
that's the main part. It's just 145. There's a 5 on the other side of that 4.
That could have been a 5.
The Apple TV. And you're gonna get an error message.
No, on each other, not next to each other, on each other.
No, you have to use the
That's not 45.
Apple TV. And you have to put a password on that, because we don't want everybody else to do it.
How would this work? Because you write like that, doesn't mean that everybody else writes just
So
like
that
that.
connects to the router, this
That
connects
could be a 45.
to my router.
You can't see the other two numbers.
And then that's probably
You don't know that. You don't know that. It could be a break in the grass. It would show it in the grass.
like this. It does. It goes up here.
For data, for one, it's 4 data.
5 grams. This way, so that's 1 centimeter up.
I know it's
I have my finger. Yep. Touch your plug. No, that's just a function of the iPhone.
Okay.
What don't you understand, huh? Okay, it's showing the relationship between. Looks weird. Why doesn't that look like? Why does her graph look like your graph?
Mr. Rick. So, really?
Yeah.
We really got these two graphs.
So,
That's cool.
so you guys didn't finish yesterday. So you're gonna have 2 dots.
Count the bottoms by 2.
Yeah.
Just draw the little line and then. You draw a line slash. I haven't done the start with the ball yet. I'm on the last.
So let's just go back. Wait, you time didn't get your shot.
So that's 4. So that's the entire thing.
Hey guys, what does the 1 on your graph on the left-hand side really stand for? That's 1 centimeter. How many millimeters is that? 10. And then 2 is 20, and so on. There you go. What are you confused about?
Why do they all be the same? Why do they all be the same? I just did this all wrong.
20, 30, 40.
It's fun.
And what now?
Why do they all be the same?
Well, if you did the same data,
You know,
you're
I'm not.
graphing the same results. They all look the same.
Huh? Graph number 2.
Oh, so if you chose which one? 6 centimeters is 6 millimeters. So it's right there. So
Be quiet.
yeah,
Yeah, they were moving.
exactly.
Mental live feed.
Why is your phone on the screen?
Apple TV.
He said he just
Oh, yeah, well,
He's like scared now.
I'll stay at the little side.
Dude, it's how
Chris, can you do this today?
Maybe, I don't know. I can't tell if it's on.
My phone is right here.
Yes, mine.
Marcus, waiting.
You're wrong.
Look at the same.
Average of it. And who comes? I actually did it. I thought they were doing it. I
it all the way up to like the decimal points. Our deepest one is only 1 centimeter, the second one is the crest. But the rest of these are all in the
Why do
ground,
you think,
because it was small, or for the depth, it was less dense.
because it, yeah, diameter's not gonna, at some point, diameter's not gonna change, it's just gonna sit.
And for the diameter, one of the holes, it didn't weigh as much, so it was like bigger than round.
Right,
Kind of bigger.
bigger diameter. Who's done ejecta yet? Everybody done
Can
ejecta?
we do all of them, or just?
You just do, yeah, you do ejecta on that second graph.
Who do you think I just did? Where are the 27 going?
So, but your masses have changed significantly. Yeah. So they can't be on top of each other, the masses are this way. The masses were all.
Wow, what is very active graph.
Okay.
I was gonna have to do it.
Here's like 60 and the rest is like 11. Bigger.
Okay, got it.
That's awesome.
This is kind of a walk around, don't panic. This is kind of a walk around Elmo that Miss Ash wanted to come over and take a peek at. What it's gonna allow us to do, instead of you bringing your graph to me, well, I was never know where to put my hands. Bringing your graph to me, I can take the projector or the, I'm sorry, I could take the webcam to you. For your applications for this, maybe next year, we'd be able to do I know you're all working so hard on your Romeo and Juliet scenes, but you could do one in a hallway where, or down in the choir room that people could see in your classroom. It would project it. Okay. All right, let's see what you guys got. So I just walk over here, and would you walk us through which one this is, hon?
That's the one,
Big voice.
the one with the mass of the object and then the depth of the crater it made.
Okay, can you see, can I see the other one? Can I see the ejecta one? All right. What relationship do you see between the mass and the length of, I'm sorry, not everybody's paying attention. At least not to this. What do you see about the relationship between the mass of the impactor and the length of the ejector?
Pretty much
Alright.
if there's a bigger mass, the strength of the impact will be longer.
Very good, very good. Yes, Lyle?
For the back one, do we use the average or do we use?
Use the average.
Okay.
Use the average. So I'm gonna take a peek at Miles here, doing his. Walk us through it. Big voice.
Well, this is the first one.
Okay,
I went by fives on the bottom for the mass.
okay,
I was up like 10, so I had it set up.
okay.
And then the first one, I had 11, 25, 1, 4, and then the second one, I had 17, I think.
Okay.
And then the third one, I had 8 and 19, and this one I had,
Why do you think that one dropped so much?
I think it was the littlest one.
The littlest ball.
And
So
then-
you're doing depth.
Yeah.
Nick, did you have something to add about that?
For depth,
Yeah.
the one was less dense, so it would cause us some impact, I don't remember.
Well, no, you talked about the fact that at some point, I think you did diameter. Did you do diameter?
Yeah.
And so what, here we go. Talk to the camera, Nick. There you go.
For the diameter one,
Uh-huh.
one of the balls that weighed less, but it had a bigger diameter, so it made the crater bigger because there was more room for surface area on the ball that hit it.
But, so the diameter stayed the same, but what happened to the depth?
The depth got less deep because it wasn't as dense.
Wasn't as dense. Okay, thank you, thank you. You guys, you did a good job. Now,
I don't know, maybe.
That's
so, look at the question. What's the formula for force? I gave you some hints. What's the formula for force?
Mass.
Say again?
M multiplied A equals
Try to put the F on the left-hand side.
Oh, so F equals mass times force equals mass.
Yeah.
Force equals mass times acceleration.
So,
Is that right?
Yeah.
But then how do you find acceleration?
Ah, how do you define acceleration? How do you define acceleration? What's accelerating your object?
Gravity. Gravity.
Gravity is accelerating your object. Okay? So the force of the object is going to be determined by its mass and by
Gravity. Acceleration.
acceleration. But now hold on now, CJ. How can you change the acceleration?
Is it higher?
force.
Change the,
Mass.
well, that certainly would. But if you want to keep the mass the same, how can you change the acceleration? Change the height. Change the height. Look at the last page. We have 30 minutes. As a group, create a new lab with a new data chart that is going to test out a new hypothesis. Now, you've already told me the constants that you have and the things you can change. How many things can you change at a time? One. So if you choose to change height, that's the only thing you're going to change. Height will be your what? What kind of variable will height be? Height will be the independent variable. Okay? Everything else will stay the same. How many different impactors will you use?
4.
We impacted
No. 1.
Oh, one.
Go ahead.
One.
One impactor. So your data sheet will look the same, but your labels will look different. Your columns will indicate what? What will your columns indicate?
Each wall.
Well, certainly 4 different trials, right?
4 different.
4 different heights. 1 impactor. What else will change about that data chart? Fine. Here we go. Me and you will walk through it together. Ryan, will you have across the top impactor A, impactor B, impactor C, impactor D? But in your new lab, if you're going to test your hypothesis that holding the impactor at different heights will change the length of the ejecta, would you be using different balls? No. So instead of saying impactor A, impactor B, impactor C, you might say impact A, impact B, impact C, impact D, right? Okay? So when it says describe it, what should it say instead? What should it say there instead? Instead of describing the ball, what are you going to describe instead? Or measure instead? Pardon? The height. So in row 1, it'll be height of the ball for impact A, height of the ball for impact B, height of the ball for impact C, height of the ball for impact D. Do you need the mass?
Hopefully it remains the same.
Yeah, it would be okay to put it in there, right, but it's gonna remain the same, you're absolutely right, Ellen. Do you need the crater diameter? Is that part of your hypothesis? I don't know, might be a part of yours. Do you think the crater diameter is gonna change based upon the height you drop the ball? Nick had a little comment about that a few minutes ago.